All right, so in this video, we're going to look over solution stoichiometry. And we already did stoichiometry when we were doing balancing equations. So the numbers that go in front of molecules when you make an equation, those are stoichiometric coefficients. And we can use stoichiometry to tell us when we convert from one molecule to another, what is the conversion factor, right? And we're gonna look at how we can use stoichiometry when it comes to solutions where we're working in volumes and molarities. So for this, since we're not actually doing an in-class lecture today, what I would like you to do is pause the video when I do questions like this, try to solve it, and then come back for the answer. If you're just watching for the answer without thinking about it first, you're not really going to be able to learn this material. So please do think about it, answer it, and then come back for the answer. So our first question here is that for the equation, 3 moles of NaOH plus 1 mole of H3PO4 goes to 3 moles of H2O plus 1 mole of PO4 3 minus and 1 mole of 3 moles of sodium. What unit do you need to be in to convert from NaOH to H3PO4? Right? And we did mention this a couple times already in class, but in an equation, if you want to convert from one molecule to another, the only unit that can do that is moles. So when you're converting from one unit to another in an equation, make sure you are in moles and moles only. Now, here's another question. So stop the video, read it over and try to answer and come back when you have an answer. So we have 250 milliliters of 2 molar NaOH. Mathematically, what do you have to do to determine how many moles of NaOH you have? Right, so remember that 2 molar is 2 moles divided by 1 liter. Big M, molarity equals moles divided by liters. So to get moles by itself, you have to get rid of those liters. And the way you do that is you multiply your meters, or not your meters, sorry, your molarity by your volume in liters, which would be the 250 here. So you multiply 2.0 by 0.250 liters. And the reason why it's 0.250 is because I converted milliliters to liters. There are 1,000 milliliters in 1 liter. All right, so here's another question for you. So the same equation we were working on previously, instead of a question mark, that should be an arrow. So if you have 250 milliliters of 2 molar NaOH, how much H3PO4 must I use to completely react with my NaOH if my H3PO4 has a molarity of 1.25? So the first question I want you to answer is simply, what units should my final answer be in? So let's reread the important part of the question. How much H3PO4 must I use to completely react with my NaOH? So your unit should be liters of H3PO4, because that's what the question is asking us. How much, and when a question in chemistry says how much, that's the volume of H3PO4 must I use. Now let's actually go over the math of this. So I have 250 milliliters of 2 molar NaOH. How much H3PO4 must I use to completely react with my NaOH if H3PO4 has a molarity of 1.25? All right, so our final answer should be liters of H3PO4. And I start with NaOH, right? So remember, if I'm starting with NaOH and eventually my answer is going to be an H3PO4, the only way to convert between one molecule and another in a chemical equation is if you're in the unit of moles. So my first step is to figure out how many moles of NaOH do I have. And we just did that on that Slido question. You have to take your molarity of NaOH and multiply it by your volume. So this will be 2 times 0.250. Let me do that calculation really quick here. That is 0.500 moles of NaOH. All right, so we know how many moles of NaOH we are using in this equation, and that's going to react with H3PO4. So my next question is, how many moles of H3PO4 react with 0.500 moles of NaOH? And that's where stoichiometry comes in. So for every 3 moles of NaOH I have, that reacts with 1 mole of H3PO4. So I start with moles of NaOH. For every 3 moles of NaOH, I have 1 mole of H3PO4. Moles cancel because you have one on the top, one on the bottom. You're left with moles of H3PO4. So this will be 0.5 divided by 3, which is 0.167. So when you have 250 milliliters of 2 mole NaOH, according to this reaction, that can react with 0.167 moles of H3PO4. All right, my third question, which I'm going to put at the top because I'm running out of space, is if I have 1.25 molarity H3PO4, what volume contains 0.167 moles of H3PO4? So I'm going to start with my 0.167 moles of H3PO4. In molarity, remember that's moles divided by liters, so that's for every 1.25 moles of H3PO4, that's 1 liter of H3PO4. Moles cancel out. Do the math. That is 0.167 divided by 1.25. So that is 0.133 liters H3PO4. That is the answer to my problem there. I need 0.133 liters of H3PO4 to react with 250 milliliters of 2 molar sodium hydroxide. So that, I know these problems can be complicated. That's why we have 2 practice problems for you to do on your own. So try this practice problem. Pause the video as I make the arrow that's supposed to be there. See if you can come up with an answer. If you get stuck, rewind the video, see what I did on the previous one, try to follow those same steps, come back when you have a solution. All right, so I have 1.25 liters of 0.125 molar HCl. It reacts with 1.75 liters of magnesium hydroxide. What's the molarity? So my final answer should be molar MgOH. Right now, remember that's moles divided by liters. So I have liters of MgOH. So I need to find this. I need to find moles of MgOH. I know how much HCl it reacted with. And I know the stoichiometry of the two. So my plan is to get moles of HCl and convert to moles of MgOH2. And we just looked at the previous problem, how to get moles of HCl if given a molarity and a volume. So let's start there. So I have 0.125 moles of HCl for every 1 liter of HCl. Multiply that by my total volume. Liters cancel out. And the amount of moles you have to 5 times is 0.156 moles of HCl. Now I can use stoichiometry to convert from HCl to magnesium hydroxide at 0.0156 moles of HCl. For every 1 mole of HCl, or sorry, 2 moles of HCl, gotta look at the coefficients. I react that with 1 mole of MgOH2. Moles of HCl cancel out. So the amount of MgOH2 I have in this reaction is 0.078 moles of MgOH2. However, we're not done yet, because remember, my answer should be molarity, so I have to take my moles divided by the volume of MgOH2 I have. So that's 0.078 divided by 1.75. My molarity of MgOH2 is 0.446 molar. Right, so we have one more problem to do here. If this is getting really confusing for you, you're not sure, please email me, go to SI sessions, come to my office hours, and we can work through it. But let's go to our last practice problem, one I just added for this lecture. So it's not on your notes. So you have, and as you can see, since I just added it super quickly, there's an A there instead of an actual number. So this should be a 2. Right. So if you have 0.555 molar calcium chloride, how much of that, so what volume, react with 1.25 moles of silver nitrate? So we're already in moles of silver nitrate. So that's fine. We want to convert to liters of calcium chloride. So I need to convert from moles of silver nitrate to moles of calcium chloride. So 1.25 moles silver nitrate. Stoichiometry, for every 2 moles of silver nitrate, I have 1 mole calcium chloride. So this is 0.625 moles of calcium chloride reacts with that much silver nitrate. Now I have a molarity of calcium chloride, so I have to figure out what volume has 0.625 moles. So for every 0.555 moles of calcium chloride, I have 1 liter of calcium chloride. Remember, big M equals in this case, 0.555 moles for every 1 liter. Moles of calcium chloride cancel out. I'm left with liters of calcium chloride. So that's 0.625 divided by 0.555. That is 1.13 liters. That is how much calcium chloride you need to react with that much silver nitrate. And that is the last praxis problem I have for you. So again, if you have questions, please let me know. Please visit office hours. Otherwise, I will see people on Wednesday. Have a good one.